Today we're going to be continuing divisibility rules, and so you can go ahead and open up to the next available page in your notebook and put today's date. And you can title your notes Divisibility Rules Continued. So we're just continuing notes that we've already done. So before we actually jot down any notes, I just want to go back a page and remind you that we wrote down all of our divisibility rules that we're going to use on page 63. And we had a rule for 2, 3, 4, 5, 6, 9, and 10. And so make sure you're flipping back to this as we look at some examples today so that you can remember what the rules are for each number and look at the examples as well. So today we're just going to basically be looking at some examples. And so you're going to create a table in your notes. So we're going to start with in the margin here, we're going to use this to write down the number that we're working with. So whatever number we're actually going to use for the divisibility rule. Okay, the next column is going to be where we're going to write down the sum of the digits because our rule for divisibility by 3 and 9 both require us to find the sum of the digits. So sum of the digits. So this is where we're going to add the digits in the number. And then after that, we're going to put the numbers that we're checking for. So we're going to check divisibility by 2, 3, 4, 5, 6, 9, and 10. Okay, so pause the video if you're not done creating your table, and then when you are done, you can go ahead and unpause it, press play. All right, so we are going to look at 3 different numbers today, and we're going to determine if each of these numbers are divisible by 2, 3, 4, 5, 6, 9, and 10, or 10. So the first number we're going to look at is 71,246. So what we're looking to do is check to see whether this number could be divided by 2 without having a remainder. So we want a whole number answer. Then we'll check 3, 4, and so forth. So 2 of our rules require us to find the sum of the digits, so I like to do that right off the bat. And so I'm going to take each digit and I'm going to just add them all together. So 7 plus 1 plus 2 plus 4 plus 6. So let's see here. 6 and 4, that's 10, 11, 12, 13, plus 7 is 20. So the sum of my digits is 20, and we're going to need that as we're figuring out our divisibility here. So let's start with 2. I know my rule for 2 is that the last digit has to be an even number. So if I take a look at my number here, it ends with a 6. 6 is even, and so it is in fact divisible by 2. Next I have 3. My rule for 3 is that the sum of the digits must be divisible by 3. Well, 20 cannot be divided by 3 without getting a remainder, so it is not divisible by 3. And if you want, you can put an X there or leave it blank to show it's not divisible by 3. All right, next my rule for 4 is that the last 2 digits create a number divisible by 4. So I have to figure out if 46 can be divided evenly by 4. Well, I know that 4 goes into 44 and 48, but it does not go into 46. So that doesn't work. Next, my rule for 5 is that it ends with a 0 or a 5. Well, this ends with a 6, so that doesn't work. My divisibility rule for 6 is that it must be divisible by both 2 and 3. Well, I already checked both of those, and it's divisible by 2, but not by 3, so it's not divisible by 6. And then divisibility by 9, again, the sum of the digits must be divisible by 9. 9 won't go into 20. And lastly, to be divisible by 10, the number must end in a 0. So this does not work. So this one's actually only divisible by 2 out of all these options. Let's try another one. This next one we're going to look at is 3,528. So again, let's start by just adding the digits. So I'm going to add 3 plus 5 plus 2 plus 8. So go ahead and add those up. 3 plus 5 is 8, plus 2 is 10, plus 8 is 18. So I'm going in order for my divisibility rules. It's okay to jump around. I like to go in order so I don't miss something, but that's up to you. So first thing, divisibility by 2, the last digit has to be even. Well, 8 is an even number, so this number is divisible by 2. For divisibility by 3, the sum of the digits must be divisible by 3. Well, I know that 18 can be divided by 3, so it's divisible by 3. Okay, next is 4. So divisibility by 4 says that the last two digits form a number divisible by 4. Well, 28 can be divided by 4. We would end up with 7, and so it is divisible by 4. To be divisible by 5, it needs to end in a 0 or a 5. That's not the case here, so that doesn't work. For divisibility by 6, it must be divisible by both 2 and 3. Well, I checked those both off already, so automatically I can check off 6. And then for 9, the sum of the digits must be divisible by 9. 18 is divisible by 9, and so that checks out. And then lastly, for it to be divisible by 10, needs to end with a 0, and it doesn't, so it's not divisible by 10. So 3,528 is divisible by all of these except 5 and 10. All right, for this last example, we're going to do 14,160. And what I'll have you do is go ahead and pause the video and try this one on your own. And then once you think you've got it, you can play the video to see if you've solved it correctly and make any corrections if needed. So I'm going to start with the sum of the digits. So 1 plus 4 plus 1 plus 6 plus 0. All right, 1 plus 4 is 5, plus 1 is 6, plus 6 is 12, plus 0 is still 12. All right, so divisibility by 2, the last digit is even, so it's divisible by 2. For divisibility by 3, the sum of my digits is 12, and I can divide that by 3, so the whole number is divisible by 3. For 4, I'm going to look at the last two digits. So I see I have the number 60. 60 is a number I can divide by 4. So the whole number is divisible by 4. For divisibility by 5, it has to end in either a 0 or a 5. I've got a 0 here, so that checks out. For 6, the number has to be divisible by both 2 and 3. Well, I've already checked 2 and 3, so I can check 6. 9, we have to go back to the sum of the digits. 9 is not going to go into 12 without a remainder, so it's not divisible by 9. And then lastly, I have 0, or not 0, sorry, I have 10, and it has to end with a 0 in order for it to be divisible by 10. And so I see it ends in a 0, and so we know it must be divisible by 10. Okay, so you just want to make sure you're going back to your divisibility rules as you're looking at these numbers. Today you're going to be working on an assignment that looks just like this, and you want to make sure that you have your divisibility rules out, which you can find on the previous page, and use those rules to kind of help you figure out if each number is divisible by 2, 3, 4, 5, 6, 9, and or 10, just like what we did here.